In this video, we're going to look at probability distributions. So we're going to start by introducing the idea of something called a random variable. So a random variable is a variable whose value depends on the outcome of a random event. And in particular, we're going to look at something called a discrete random variable. So a discrete random variable can only take certain values. We think about the scores when we roll a dice, for example. The scores on those dice are examples of discrete random variables. So we can represent discrete random variables in two different ways. We can use something called a probability distribution table, which is something you're probably more familiar to seeing from doing probability at GCSE, and also something called a probability mass function. And we're just going to go through basically what those two things are here. So we're told to let x be the random variable representing the score on the spinner. So I've got a spinner here with 8 equal sides, but some of the values there appear more than others. So one way of representing that would be in a probability distribution table. So I've got my values of x, which are 1, 2 and 3, and also within this table we've got the probability that our random variable x is equal to each given x value. So the probability that capital X, representing our random variable, is equal to the given values of x here. And I can draw a table from that information there. And then basically we can say, well, there were 8 sections in total. The probability that our random variable is equal to 1 is the probability that 1 is our outcome. So that is, there's 2 of those, so that's going to be 2 out of 8. For 2, there is only 1 of those there, so that's 1 out of 8. And then for 3, there are 1, 2, 3, 4, 5 of those, so that is 5 out of 8. Now that's something that's probably fairly familiar to us. We've just been able to represent the probabilities on that spinner as a table. The other way we can see those represented are as something called a probability mass function. Now that is going to start again with the probability that our random variable x is equal to our given values of x, but this time we're going to write that as a piecewise function. So we're saying the probability is equal to, well, the probability was equal to 2/8 when x was equal to 1. It was equal to 1/8 when x was equal to 2, and it was equal to 5/8 when x was equal to 3. So we've got 2 different ways essentially showing us the same thing, the same information. This is writing it as a probability distribution table, and this is it written as a probability mass function. So we're going to look at an example of a question on probability distributions now. So the random variable x has a probability function as shown here. So again, we've got that written as a probability mass function, and we've got k, lots of x plus 2 when x is 1 or 2, and kx when x is equal to 3 or 4, and being asked to find the value of k and construct a probability distribution table. So to start with, we're going to consider what this looks like for each of our x values. So when x is equal to 1, we can say that the probability that x is 1 is equal to, well, if I substitute x into this top equation, since this equation applies for x being 1 or 2, I've got 1 plus 2 is 3. I've got 3 lots of k. When x is 2, I've got the probability that my random variable is equal to 2 is equal to, again in this top equation, 2 plus 2 is 4, so I've got 4 lots of k. When x is equal to 3, the probability that our random variable is 3, this time I can use the bottom equation, since I've got that equation holding true for x being 3 and 4. So x is 3, I've got 3 lots of k. And finally, when x is equal to 4, the probability that our random variable is equal to 4 is equal to 4 lots of k as well. So we've got our probabilities written in terms of k. Now, because these are probabilities and they are the only outcomes that can occur, these 4 must have a sum of 1. So I can say that 3k plus 4k plus 3k plus 4k, the sum of these must be 1. Now 3 plus 4 is 7, plus 3 is 10, plus 4 is 14. So I've got 14 lots of k must be equal to 1. Therefore k must equal 1 over 14. So I've found my value of k. The last step, we're being asked to construct a probability distribution table. So a probability distribution table is going to be a table which looks like this. So I've got my values of x and my probabilities that my random variable was equal to x. My values of x were 1, 2, 3, and 4. And the probabilities that x was equal to those values, well, if k was equal to 1/14, then the probability that x was equal to 1 was 3k, so that's going to be 3 lots of 1 over 14, which is 3 over 14. When k is 2, or rather when x is 2, that's going to be 4 lots of 1/14, so that's going to be 4 over 14. The probability of x being equal to 3 was 3k, which is 3/14. And finally, the probability of x being equal to 4 was 4k, which is going to be 4 over 14. And there we have our probabilities represented in a probability distribution table. That's the end of this video. Thank you so much for watching. For more A-Level and GCSE maths content, like and subscribe to N Jackson Maths on YouTube.